Alright, in this video we're going to be talking about function notation, what that means, and what we do with it. So moving right along, equations can be written in a form called function notation. We use this as a quick way to evaluate functions for a given input. So think back to Unit 0. When we were evaluating, remember what it means to evaluate, to substitute in a value. Now, what's different about function notation than what we are used to is that it looks different. The equations look different. If I could get my computer to work with me today, we'll go ahead and start. So instead of y in these equations, you're going to have f of x equals, and then your equation. So anytime you see this f of x, it's the same thing as y, and I'm just going to go ahead and write that. I can't spell apparently. Sorry about that. So f of x equals, and then whatever the equation is. So I know I've said this, I think, in earlier lessons, kind of leading to this point, but anytime you see y, you can interchange it with f of x. So when we evaluate these functions, we need to substitute the value in for x. Now, I'm going to be doing these algebraically and on the calculator / desmos. So let's start with this first one. So just like when we normally evaluate, we put the value in for whatever variable we're evaluating for. So if we're substituting the value in for x, every time we see an x, we're going to put this value in. So here I see f of 5, so I'm going to retype it. F of 5, because 5 is our x, equals 5 plus 7. So what this is saying is I'm trying to find the y value when x is 5. So I put x in for 5 and I solve. And when I solve this, I'm really ignoring the left part of this and I'm just looking at these numbers. 5 plus 7. Well, that's 12. So I can say that f of 5, oops, that was supposed to be a parenthesis, equals 12. This is saying our y value is 12 when x is 5. So really it's just evaluating just like we were in Unit 0, but with a slight twist. Right, so let's do the same thing for this next problem, f of -1. So every time we see x, we're going to put in -1. I'm going to copy this. Of -1, there we go. And then I have x, well, x is -1, plus 7. Well, -1 plus 7 is the same thing as 7 minus 1. So that's just 6. So I can say when x is -1, y is 6. Okay, and then let's do this last one where our x value is now -3. Okay, so -3 plus 7 is the same thing as 7 minus 3, so that's 4. So f of -3 equals 4, or when x is -3, y is 4. Let's do one more example from these algebraically, and then we're going to jump to the calculator. So we're going to go down and we're going to do number 5. So h of -4 equals 3 times x, which is -4 squared. Because I'm typing it, I can't really do exponents, so I'm using this little caret, plus 7. And then I just need to go ahead and evaluate this. Well, I have to do my exponents first. So -4 squared is 16. And then I can multiply this to get 48 plus 7, which then is 55. Yep. Actually, I could have left that up there. So, what this means is when x is -4, y is 55. So once you get the hang of this, it's not bad. It's really tedious more than anything because you're just repeating the same process over and over again, putting it in for x and evaluating, putting it in for x and evaluating. Right? Moving on to the next one. This is going to be for b, where we have h of -2. So we need to go ahead and change all of our x values to -2, to the value -2, and solve. Right? Just like in the last example, we need to square this first. -2 squared is 4. Three times 4 is 12. And then when we add 7, we get 19. So h of -2 equals 19. So when x is -2, y is 19. So for the very last one, we have h of 0. I'm going to go ahead and anytime I see an x, I'm going to put 0. Maybe. Right? But 0 squared is 0 times itself. 0 times anything is 0. So this is still 3 times 0 plus 7. Well, we just said anything times 0 is 0. So this is going to be 0 plus 7, which is just 7. I was about to say 0 again, sorry. Which is just 7. So when x is 0, y is 7. What we're going to do is going to be on our calculator. So I'm going to go ahead and pull up my calculator. And the one we're going to do on the graphing calculator is example number 4, x squared minus x. So the first thing you need to do when you're doing it on the calculator is go to your y equals and put that equation in. So x squared minus x. Right? The next thing you want to do is go to your table. So tables above graph. And you see all of your values. Now, I'm not going back and forth to the notes because I have it written down, which you should have the notes in front of you as well as you're looking through this video. But now I can go through this and find the x values I'm looking for and figure out the y values. So the first one for number 4 was f of -4. That means I need x to be -4 so I can find out what my y value is. And here, because we put that equation or that function in to our calculator, it's kind of doing the work for us. So here it's saying when x is -4, y is 20. So I'm going to write that down, and then I'll go back and put it on the notes here in a second. The next part, or part B, said f of -1. So I can look here, when x is -1, y is 2. And then my last number is 7. So you can either scroll back down or go into your table set, so second window. And I can say I want this to start at 7, so I don't have to scroll all the way down. Go back to my table, and it will put me at 7. So when x is 7, y is 42. Now this is a kind of cheat way to do this. You should be able to evaluate them by hand if asked, but there is this option as well. So because we did this one in the calculator, I'm just going to go ahead and type what these values equaled instead of putting everything in and solving for it. So equaled 20, this one equaled 2, and this one, equaled 42. So that's a quick way to put it in your graphing calculator and evaluate it using your table. You just have to remember what it is you're looking for, and remember what x values you need. And then we're going to do one more in the calculator, but we're actually, not in the calculator, we're going to do one on Desmos. And we're going to do number 10 in Desmos. Let me go down to that one. So the absolute value of x minus x squared. Right, so in Desmos, I'm going to pull up my little keyboard and click my absolute value sign, and I need x minus x squared. And then what I want to do is go up to my gear wheel, and I want to convert this to a table. So it's going to give you a couple points from the table already, but none of these points are the values of x we need. So we're going to add these values to the table. So we need g of 4, g of -7, and g of -3. So when x is 4, y is 12. When x is -7, y is 56. And when x is -3, y is 12. So I can zoom out. And here is -3 and 4. Then if I zoom out a little bit more, there's that -7. So g of 4 equals 12. G of -7 equals 56. And g of -3 equals 12. So you can use your calculator or Desmos to evaluate these, and it'll work very similarly. Just how you do it on Desmos and how you do it in the calculator is just a little different. We are not going to go over 11, but I would like you to try it, and if you have any difficulties or have questions, message me and we can work through it together. I do want to talk about 12. I know I said that you could use the graph. Oh, no, I didn't say that. Oh, I meant to say in Desmos, you could look at the graph as well and evaluate from the graph, and how you do that is kind of like you evaluate it algebraically. The only difference is you're actually looking at it on the graph. So I'm going to make this line really fast. So we're going to do just a couple of these because I want you to try them. So we're going to do A and we're going to do D. So f of negative 4. When x is negative 4, so that would be this value right here, we're trying to see what is the value of y. So if we look on this graph, when x is negative 4, y is this point right here, which is 3, 2, 1, 2. Sorry, I misplaced my x-axis. So when x is negative 4, y is 2. And then we could do the same thing for f of 5. When x is 5, what is the value of y? Well, when we look where the graph is, it touches right here, and this would be at negative 1. Right, so when you evaluate from a graph, you really just look at it and look where x is compared to y, or vice versa. Moving on to the next page, now it says, given the domain, find the range values. So now we are given a list of numbers that we have to find the range values for. So we're going to do one of these algebraically and then one of these in Desmos. And we're going to do 8 and 10. We're going to do 8 algebraically. So if we're doing this algebraically, what we need to do is the same thing we were doing before. For every value in the domain, we need to substitute that in for x. So for the first number, or the first value, f of negative 1 equals 3 times negative 1 plus 1. And then we can start solving this. Well, 3 times negative 1 is negative 3, and negative 3 plus 1 is negative 2. So I can say f of negative 1 equals negative 2. Right? Moving on to the next value, I think that was 0. Yes. So f of 0 equals 3 times 0 plus 1. Well, anything times 0 is just 0. And then 0 plus 1 is just 1. So f of 0 is 1. Okay. The next one is positive 1, so f of 1 equals 3 times 1 plus 1. 3 times 1 is just 3, and then 3 plus 1 is 4. So f of 1 equals 4. And then last but not least is 4, so f of 4, that becomes 3 times 4 plus 1. 3 times 4 is 12, and 12 plus 1 is 13. So f of 4 is 13. The last thing to do after you've done this algebraically is to write in the range values using your curly brackets. Remember, it has to be least to greatest, so negative 2, 1, 4, 13. And that is your final answer. Now let's do number 10 in Desmos, 3/5 x plus 2. I'm going to get rid of the one I have and add a new function. Oh, first. And I forgot I zoomed out, so let me zoom back in. Okay, so with this, I'm going to go back to my gear wheel, convert this into a table, and I need the values negative 10, 0, and 5. Well, I have 0 here, but I need negative 10 and 5. I could put 0 again, and it would just show me that same value. So if you wanted to do that, you are more than welcome. So our range values for the given domain is -4, 2, and 5. So if you're doing it on a calculator, it takes less time. But you do still need to be able to do this algebraically if asked. Okay. So I'm not going to go through these other examples because I want you to try it either algebraically or on the calculator or Desmos. But the answer key is posted for those. We're going to move on to the next page. Now, a lot of this is copied from the very first page of notes. So we're not going to fill this part in again. However, this part is different. If given f of x equals a specific value, substitute f of x with this value and solve for x. So we're going to do one of these algebraically and then one of these in the calculator. And I'm going to scroll down and we're going to do 4 in the calculator. Oh, excuse me, I'm still tired this morning. So 4 in the calculator and then 5 algebraically. So now if you are looking at these examples, these say g of x, h of x equals some number instead of g of some number. So this is saying this is the value of y, and we need to find x. So when we are doing this, we're going to substitute this value in for g of x, not in for x, but in for the entire piece g of x and solve for x. So that's going to look something like this. If g of x equals 7, I'm going to start with 7 equals -1/2 x. I need to put 1/2 in. Plus 9. So x is there because we don't know what it is. And then we are just simply solving from this point. So notice that the g of x is completely gone and I've replaced it with 7. This is how you would solve for x and put your y value in. So now this is just like a 2-step or a multi-step equation. I need to solve for x, so I'm going to go ahead and subtract 9. And then I'm left with -2 equals -1/2 x. And to get rid of -1/2 in front of the x, you can either multiply both sides and then divide, or you can do it all at the same time by multiplying both sides by the reciprocal, or taking this fraction and flipping it, so multiplying it by -2. So when we multiply this by -2, the -1/2 and the -2 become 1. So we're left with just 1x on the right side, and then -2 times -2 is -4. I'm sorry, not negative, it's +4. Because 2 negatives make a positive. And 4 equals x. And then we can put that back in and make sure it works. So 4 times -1/2 is -2. -2 plus 9 is 7. So that works. Right? And then I'm going to copy some of this because we're going to be doing the same things basically. And then I'm just going to go ahead and change some things. So now our y value is 14. So when we're still subtracting 9 because the problem hasn't changed, we're still doing that. So when we subtract 9 from 14, we get 5. we still need to multiply both sides by by negative 2. I just realized these parentheses didn't drop down as well. But when we multiply this side by negative 2, we actually get negative 10. So when we put negative 10 back in the original equation, negative 10 times negative 1/2 is positive 5. 5 plus 9 is 14. So that works. And then our last question, y is now 18. We're still subtracting 9, but when we subtract 9, we get 9. We're still multiplying both sides by negative 2, and when we do that, we get negative 18. So when we put negative 18 back in here, we get negative 18 times negative 1/2, which is positive 9. 9 plus 9 is 18, so that works. So that is how you would do this algebraically. Let's go ahead and do number 4 in the calculator. And we need to find where y is 7, 34, and 82. Right, so 3x squared plus 7. And I'm going to go into the table. And now where this is, I can see that there are 2 places that y is 82. There are 2 places that y is 34. And there's 1 place where it's 7. But let's say your table started at 0. You would only be able to see 1 value for 82, 1 value for 34, and then the 7. So make sure when you're doing this, just to kind of scroll through your table, to make sure that it doesn't repeat like this. And the reason why it repeats, let me go to the graph for a second, is because if I drew a horizontal line across this for my y values, I could see that my y values is going to touch 2 different x values for every point along this function except at the middle. So just double check to make sure that you don't have more than 1 value for functions like this one. Usually functions that are squared or cubed or to the 4th power, things like that. So we can say when y is 82, x is negative 5 and 5. When y is 34, x is negative 3 and 3. And then when y is 7, x is just 0. So if you wanted to put x equals negative 3 and x equals 3, you could do that too. So that is how you do that algebraically and in the calculator. The reason we did this one in the calculator instead of desmos is because desmos is really great for putting x values in the table and then looking for y values, but it's difficult to put the y values in and find the x's. So for solving for x, or if you're given the y value, use your calculator or do it algebraically. But if you have the value of x and need to find y, you can use desmos, your calculator, or do it algebraically. That part does not matter. Right? This is the same graph as before, but now we have y values that we're looking for instead of x's. And we're going to do b and c. So here I'm looking for the y value 0. What is x when y is 0? So when y is 0, that's going to be at this point right here, at the x-axis. When y is 0, the value of x crosses the line here. So that's going to be x equals 0. Right? And then we're going to do 2, or the value 2. When y is 2, so that would be up here, what is the value of x? Well, here I see that this crosses this line exactly at the point -4. But this one, it crosses the point, but it's not exactly at this -1. So we don't know exactly what that decimal is, so make it something very close to -1. -0.9, -0.8, -0.75, something very close. So we can say x equals -4 and whatever decimal you choose, negative decimal you choose. Right? And then I'm going to leave A and D so that you can try those. Remember, you're looking for the x value and you're given the y value here. And then in this last section, we're going to do 9 and 12. 9 we're going to do in the calculator, and then 12 we're going to do by hand. So let's go ahead and do the calculator one first. Notice now that this says, given the range, find the domain values. Kind of the same thing that we've been doing. We're given some y values and we need to find the x's. So same thing, we're going to go ahead and put this into our calculator. Go to the table, and we're looking for the values -8, 1, 10, and 16 for the y's. Well, I see -8 here when y is -3. I see the value 1 here when y is 0. I see the value 10 here when y is 3. And the value 16 here when y is 5. Now I can scroll up, but it looks like these numbers are just keep going into the negatives, and I can scroll down and see that these numbers just keep going into the positive. So I don't have to worry about these repeating. And I can go ahead and say my domain, if I could speak this morning, my domain values are going to be -3, 0, 3, and 5. And I can just list those out. Right? And remember, just like I said before, even though we did this on the calculator, you should be able to do this algebraically if asked. But let's go ahead and do 12 algebraically. So we are given this range. That means we need to put these values in for f of x and solve for y. So -3 equals 7 minus 1/2 x. And we are now solving for x. So here, because 7 is positive, I need to subtract 7 on both sides. And when we subtract 7 on both sides, we get -10 equals -1/2 x. And then we're doing the exact same thing we were doing before, multiplying by the reciprocal, so we need to multiply this side by -2. So here, that's going to be +20 equals x. And then double check it. If we put 20 in for x, 20 times -1/2 is -10. 7 minus 10 is -3, so that does work. I am going to go ahead and copy this again because the work is the same, and then I'll just change the numbers. Right, so now our next value is 0. We're still subtracting 7. When we subtract 7 here, we just get -7. And when we multiply that by -2, we end up with positive 14. And then to check that, we put 14 back in, so -1/2 times 14 is -7. 7 minus 7 is 0, so that works. And then for our last value, we need 8. So 7, we're subtracting 7 on both sides. 8 minus 7 is just 1. When we multiply that by -2, we get -2. And when we put that back in to x, -2 times -1/2, well, that's just positive 1. So now we're adding. 7 plus 1 is 8. So I can say our domain values from least to greatest are -2, 14, and 20. And that's really all there is to it. I know we didn't do a lot of these examples together, but I do want you to try these other examples, do the practice, come to me with any questions you may have, and we can go over anything.